I cannot. Oh, no, that's okay. Yeah. Hey, guys. Hey. Sit here. What's the connection type? HDMI. Okay, we're finally in the future. This is it's like our working system.
Yeah.
I saw them at Cisco Live. So oh, thanks for that. It's over our shoulder.
Laptop, John, with these slides.
It has all sorts of weird colors. But it's the only laptop that I could get that would meet our constraint. Why do we have somebody facing backwards?
It's for the sign language, as far as I know.
Oh, okay.
What's it?
2.4%
Okay.
It's not the same as that.
I didn't know.
Should we start?
Yeah.
So hello everybody, welcome to the Lisp working group. You had a few minutes to read again the not well. Just as a reminder, it says whatever you say today is a contribution to the IETF, this room. Okay, so choose the words carefully. So the usual pointers. I'm Luigi. Here beside me, Joel, we are the co-chairs. Padma didn't make it this time. She would join in remote. She will anyway guarantee some minutes as usual. Thank you very much to Padma. And all the material is online and available. Okay, so this slide shows the situation of the documents 3 months back in Prague. And the progress is this one. You catch the differences? So the Lisp RFC 8113 bis is now in the RFC queue, just waiting for a missing reference. The young model is under review by a young doctor. So this is Chris Hobbs, and I met him this morning, and there is a mismatch in that document between the model and the tree. Alberto.
Oh, it's my fault now.
You are one of the co-authors. Fabio, you're right. I go higher in the hierarchy. Fabio. No. The point being is that today or tomorrow, Chris will contact you and show you the issue so that this can be solved. I mean,
Thanks for
yeah. So other than that, doesn't mean we did nothing, but actually Albert will present what we did in the main documents. This will be the first presentation that we have today. Then another update on the Lisp security document. And then we have a few presentations that are not working group items. So actually Prakash didn't make it. So he will not present Lisp site external connectivity. So we have more time for discussion at the end or for... sorry. So it didn't work. Basically, he made it, but you were on holidays. No. So we will have Lisp overlays. Dino will show us the Lisp tracer route tool and make a demo on the mobile node. And finally, we will have Sharon that will present again with more time for questions, especially the distributed geospatial Lisp Blackboard for automotive. Okay. There is any comment on the agenda or anything you want to change? Nope. Thank you. So Albert, please. Yeah, should work.
Thank you. So I think that yes, we work since last.
Wait, the mic is off. Yeah.
Hello? Now it works. So I think that we work since the last IETF. So I'm going to summarize a little bit the changes on the 6830 bis and 6833 bis since the last IETF. So basically, we posted a new version of each of those documents, both in June 2019, so 1 month ago. And then hopefully we have addressed all the comments made by the reviewers. This is up to them to decide, of course. So we posted the version and then we send an email to the reviewers telling them, okay, here you have the new documents. And now I'm going to outline a little bit the changes. There are many, many changes. You can check the diffs. And I'm summarizing them into these 4 items, which is security, rate limiting, MTU, and other. And I'm not going to divide the changes into data plane or control plane, but I'm going just to mix them because I think it's a little bit easier to follow. So the first change is that now gleaning, map versioning, and locator status bits and econons should not be used over the public internet. That's the recommendation that we have written on the spec. This is because on the public internet there are some issues regarding those mechanisms. And then also locator status bit should be used with map versioning when map versioning is in use. So that's the first one. The second one is regarding how we compute the keys on map register. No, how we authenticate map register messages. Okay, now what we do is we use the pre-share key not to compute the HMAC that authenticates the map register, but rather to derive another key, which is the one that you use to authenticate the map register. So in the map register, you have this algorithm ID, and this algorithm ID typically was pointing to the right algorithm ID to HMAC the map register, but now it's pointing to a new table, which is telling you which MAC algorithm you have to use and which key derivation function you have to use. So this way we don't change the map register the way it is. And the way you authenticate map registers is first you pick your you pick your KDF, your key derivation algorithm based on the algorithm ID, and then you also pick the MAC algorithm based on the algorithm ID. So you have to pick this field will tell you which algorithms to use. And then you have to first of all take your pre-shared key, which is step number 3. And then once you have all these 3 things, what you need to do is you need to derive a new key. And the way to derive the new key is you apply the key derivation function algorithm that you have choose with the nonce S, which is a simple, it's a constant, it's a string which is a constant, which is equal to map register authentication, and then the pre-shared key. And then the key that you obtain with this is the one that you will use with the MAC algorithm to compute to hash the whole map register message and to authenticate it. Then some other comments or small changes is that the nonce is incremented each map register to prevent anti-replay attacks. We discussed this 3 ITFs before, but we need to clarify that this is indexed by the nonce is indexed at the map server by the XDR ID and the key. Then also the key, the pre-shared key which we use, we also specify that the pre-shared key that we use to authenticate map register message is unique per ETR, which was not clear on the previous version. And then we also rewrite the security sections discussing all these changes. Sorry, this title is wrong. It should be rate limiters. So in terms of rate limiters, there is an RFC, which is 8085, which defines some guidelines on rate limiting UDP applications over the internet. So we are following those guidelines, and map requests must be rate limited to 1 per second per EID prefix. And then in order to be in line with the spec, what we do is that after 10 retransmits, you have to wait for 30 seconds. So overall, you are sending 1 packet on average each 3 seconds. The map reply must be rate limited 1 packet per 3 seconds. This is per destination airlock. This also applies to SMR, to the message that SMR senders and SMR responders send. And then regarding the map register, you have an exponential backoff of 1 minute, depending on if you need to retransmit it. Then regarding MTU and following the guidelines of the same RFC, so if Lisp is expected to be deployed over cooperating entities, and if the deployers are aware of the MTU, then they can set the MTU. But if they are not aware of the MTU, this RFC states that the packet size must be limited to those 2 sizes for IPv4 and IPv6. So we have specified this on the documents. And then other small changes are that this is rather a clarification. Instance ID is a 24-bit field on the data plane. And that's it. This is what it is. Then the nonce is using to identify the corresponding map reply when you send a map request, because before some text was claiming that it was providing some anti-replay attacks. That the explicit congestion notification field is processed according to RFC 6040. And then also we clarified that whenever you receive a packet and you have to wait for a map request, map reply exchange, you can either drop or buffer the packet, and this is up to the deployer to choose which one is better for his or her deployment. And we don't provide any kind of recommendation. So this is the current status of both documents. So as far as I understand, we have only 2 discussed. And my understanding is that the next step is to wait for those discussed to respond, right? Okay. So is there any comment, question?
Yeah, just trying to understand what are the next steps here, right? Because my understanding is that we are waiting for the discussed comment to be, for the latest version to be reviewed. And I think at this point is only Ben and Miriam, right?
Yes.
Albert, yeah. Oh, thanks.
Hi, Deborah. I forget myself. Did you actually send them mails to?
Yes, I did.
In June?
In June, yes. I can check it now again. Yeah, right?
Okay.
Yeah.
Okay.
Yeah.
I would, if you can this week, try to grab them and ask if they had a chance to look at it,
Okay.
and I'll try to remind them too. And definitely next week we'll get on them more because
Okay.
everybody's very busy right before the meetings. But we try to get them to clear them now. But if you can get them this week, that would be good in case they want to have a follow-up, right, to meet to talk about it.
Just because I didn't hear it very well, you're suggesting me to send them a friendly reminder, right?
Yeah,
Okay,
I would say
okay,
do it this
okay.
week even, and just say you have time to meet them this week if they need
Okay.
to.
Thank you.
And maybe just one additional comment, this is Fabio again, on list GPE. I have a set of comments from Myriad that needs to be applied to the document, and I just didn't have a chance to do those, but they're in the queue, so I hope I can do it shortly after the ITF, because I would like to keep this in sync with the review and align with the 6833Bs and 6830Bs. Okay.
No further questions? Thanks, Albert.
Thank you.
Fabio. Don't sit. Come here.
Oops. Nope. Okay, this is the update on LeafSec. I'm Fabio Maino, and these are the other co-authors of the document. So these are the updates that were posted on June the 2nd. So the changes, the main changes were to align LeafSec with the changes that were introduced in 6833Bs and to reflect the same mechanism that we are now use. Plus the first one here that is basically allowing an ITR to securely downgrade to non-LeafSec. This was a request that came from Ben. We discussed with him in Prague, and now the document reflects that update. The second is, you will see very similar to what has been done in 6833 to secure the map register. And the third one, there were a bunch of comments that were posted by Med earlier this year, very detailed, and Med Bukader, he does always a great job of sending comments, so I want to thank him for that. And those are being addressed, and I think he has acknowledged that they've been covered. So just to go a little bit into the details of the changes that were done, the main changes are in the authentication, ECM authentication data, and we will see that the first change we listed, regard the introduction of this e-bit, and then the other changes regard the change of the key ID and the OTK wrap ID. As you see, this is very similar to what Albert just described, and we will look into it. So for the secure downgrade, what we did was basically specify how an ITR, by using this ETR can sign bit, can specify that he is willing to accept non-signed map reply from the map server. It has to be done carefully because, attacker may take advantage if it's not done properly. And I think we go to the point where, this is well specified now and clear, and it is secure. And And then the other change is equivalent to what Alberto just described. Rather than using the pre-shared key to protect the transport of the one-time key, we are doing the same key derivation operation to derive a per message key, and we use that key this time to wrap the one-time key. So we can securely transport the one-time key from the ITR to the map resolver and from the map server to the ETR. Here are some details. You will see that basically when we identify the key wrap algorithm, we don't identify only the wrapping algorithm that we use to wrap the actual key, but also the key derivation function. And this is very similar to what Albert just described for map register, even if the security function perform is different. In that case, it was generating a key to authenticate the map register, and this key is used to transport the one-time key. Again, this was discussed with Ben back in Prague. There were also a comments from Med right after I posted the new version 19, and I have incorporated those already. I haven't published version 19 because I was waiting for more comments to come. Maybe it makes sense to publish it at this point since they haven't arrived. But thanks again to Med Bukader for always the detailed review that he posts. And and basically next steps, same consideration of what we did before. To be honest, I'm not completely sure on the status of the ListSec draft at this point, because we basically were told by the reviewer that the review of the BIS RFCs should go, together with the review of ListSec, and we have got a bunch of comments. We have incorporated those that we received in Prague, and I think that the next step is getting a feedback back from Ben and from the security directorate. That's my understanding, but we need to figure out what is actually the next step.
So if you check the data tracker, the document is in last call for 2 months.
Yeah, because we had
which is abnormal, but it's just because as you said, we received the review. So we should clarify whether or not taking out and moving it forward if the new version replies to. I don't know if Deborah.
Yeah, it's Deborah. I think it's really good that this is looking stable, and I would give a heads up then when you say to Ben that, reminding him, because I found the mail, I think all of us were on vacation around that time, just say that this one's stable now too, because that's what he really wanted. He wanted to, he was not sure the allocation of the different information, right? It should be in this document or the others. So now he can have this document also to look at and to say that everything's good.
Yeah, indeed. As far as I remember, he was looking for a complete security solution for Lisp, and this was the missing piece.
I would send him the heads up for early review. You're ready for it.
Exactly. That was my understanding again, right? That what they were really asking was to basically move forward this document together so that we have an overall view of Lisp, data plane, control plane, and security. Okay, cool. Any other questions? Okay, no. Thanks then. Thanks.
Okay, so now let's talk a bit about overlays. So this is a draft that Peter submitted a couple of ITFs back. I'm going to give an update. We haven't given an update since the last time Victor presented. So I think this was in Bangkok, like 2 ITFs ago, that he brought the draft here. We got some comments from both the chairs and the working group in general about what the draft was trying to solve. So we have revisited the draft. We have added some text that clarify what's the focus on the draft, and in particular, we describe how this helps interoperability between different Lisp overlays. We have done minor fixes through the text as well. and the version 01 is posted. It was actually posted last ITF, but we didn't present it back then, so we are presenting it now. So what is this overlay thing? So the basic idea here is that, and this is coming partially from operational and deployment experience that we are gaining on Lisp, right? That in some cases you may want to have different Lisp overlays that use either different control planes or different encapsulations for a variety of reasons, and you want to make them interoperate. So the way to do that is via what we call an overlay. There is a name that Fabio came up with, and we found it really funny. So we connect the different site overlays via an overlay, and then you have border XTRs that connect the site overlays with the overlay. Why is that? As I was saying, interoperability is one of the biggest reasons for this control plane. So you can have different mapping systems running in each of the overlays, and then they can exchange mappings through the overlay. And also data plane that I think we were not clear the first time we presented this on how important it is from a deployment perspective to have the flexibility to have different data plane encapsulations, different addresses on the underlay in order to deploy Lisp in a feasible manner. So the structure of this is that, as I was saying, multiple site overlays connected through a common transit overlay. This allows different alloc spaces. So think of, for instance, the site overlay on the left may have private addressing on the underlay, and the scope of that private addressing can be constrained within that site overlay. Also, when you have an overlay in the middle, you don't need to be aware of the routes to reach the remote overlay. So the amount of entries on the underlay is greatly reduced, which is a good thing. So you have less routes on the underlay to deal with. And you can have different address families, of course. And then fate isolation and survivability. So parts of the network may die and the rest operates as if nothing happens. So let me go.
May I?
Sure, go for it, Luigi.
So basically the overlay is an overlay with specific purpose to connect.
That's correct. So that is correct.
Okay. Next question is, can I have several overlays connecting different site overlays, and these overlays can interconnect between them?
That is an excellent question. Actually, it's in the list of next steps. So in the draft right now, we consider a single overlay. We have discussed on what to do with multiple overlays. That comes with a different set of requirements and assumptions that we need to evaluate. I mean, theoretically, yes. We have not addressed that yet on the draft. So that's on the next step for us. But that's a good question.
Dino, I want to respond to the question too. It turns out to have multiple overlays is less desirable than to have good multi-home connectivity on the underlay that the overlay realizes, because the overlay is just there to connect the edge points of the other overlays and nothing else. And it's not clear that you need separate policy where you need a separate overlay structure to interconnect. So that's why we first started off saying we only needed one.
So I understand that you start with the simple solution, but my point is not that you need several overlays. What can happen is that for whatever reason you have different overlay sites, and they decide to interconnect and deploy the overlay. And so me and you and Alberto and Fabio, we interconnect pairwise, and we use different overlays. Now, in the future, we want all to interconnect. We become a big family, okay? Now, what you do? You deploy a new unique overlay, or you interconnect the overlays? That's the
what
point.
you do is you interconnect the site overlays in another mapping system, and all the site
you
overlays.
add a third overlay.
No, I didn't say that. I said you connect all the site overlays you take all their EIDs and you sent them to a new mapping system, and it looks like a regular overlay, rather than to iterate this pattern again.
So I think that Luigi's question is, and correct me wrong, right? So you have two completely separate, like the picture you have here, but two different ones. So you have two overlays connected here, two overlays connected here, right? Exactly. And then at some point you want to bring the 4 different site overlays together. And I think that the answer is, with the draft as it is now, what you will have is the two overlays that used to be completely independent from each other, you will aggregate, so you will end up with a single overlay that connects the 4 site overlays, right?
You could connect them to the same overlay.
Correct.
In other words, you merge the 2 overlays, but that's what I wasn't suggesting. I was suggesting it's just one overlay. Yeah. Because the EIDs that are connecting this overlay to their own local mapping system could register to a mapping system that's global, and it just looks like a regular Lisp overlay as we know it today.
So, but this means you kill at least one of the overlays and you keep the other one as a general overlays.
It's not clear because you still need the overlay for the original reasons.
I mean, it's something that must be discussed in the draft.
I think that
whatever solution at the end.
I agree that we are not addressing yet the scenario where you have multiple overlays. I think that we are kind of saying the same thing here, but it's not clear. So yeah, if we need to,
I agree with Luigi. I mean, the option needs to be considered in general, right? Because it's at least theoretically possible. From a practical standpoint, this is coming out of the ICAO, to the International Civil Aviation Organization, that, by the way, has the site
here in Montreal.
And in that case, what I think will determine what you do is how the administrative domains are related, right? In that particular case, for example, the requirement is that there are some administrative domains that they will not become the same because maybe they are different providers. So this is the first level of trying to put them together with an overlay is exactly trying to get everybody talk together. And depending on how the administrative domains are, you can go to a single overlay, you can go to a single overlay, or maybe to the multiple case. And I think the draft will have to address.
I mean, at the very end, I don't know if you don't want to touch these specific points. Just state it. So the case where blah blah multiple blah blah, we do not consider in this document.
That's a good
but something we need to say something one way or another.
I agree, Luigi. That's good feedback. Thank you. Okay, so since it has been a long time since we presented this, I'm gonna go quickly over how the overlays work, right? So control plane, I mean, this is kind of a straightforward, and for you guys that have been looking at this for a while, you will see this clear. So the idea is that each site overlay has its own mapping system, and then you have the borders that subscribe to everything into that mapping in that mapping system, in that local mapping system. So take, for example, the borders on the top of the picture. Those guys are going to subscribe to 0/0 on the mapping system on the top. So they are going to get all the mappings. What they are going to do then is they are going to potentially aggregate those mappings and register the mappings into the overlay. So then with that, what happens is that within the same site overlay, the mapping resolution happens as regular in any Lisp overlay. For communication across different site overlays, what happens is that the XDRs on a site try to resolve the mapping. It's not local, it's not registered into the local site. So they go to the border, and the border is able to query the mapping system on the overlay and find which site overlay has that mapping and send the traffic there. This is the flow with the data plane, as I was saying, right? So any hit on the 0/0. So if there is a mapping missing in the site overlay, you're going to send the traffic to the border, from the border through the overlay to the remote border, and then to the destination XDR. So next steps, and I think we already have this discussion right now. First, we want to have some discussion on this on the mailing list. So after the meeting, we will send a mail to the mailing list asking for discussion. Then we would like to check with you guys and with the chairs if you think that this is a topic that the working group should take. So we are not saying that the draft is final on SKRM4, and as Luigi pointed out, we need maybe to address the challenges of having multiple overlays, but we would like to know if the working group should take upon this draft and make it a working group item. And yeah, the questions that you have here at the bottom is precisely what we're discussing. So how do you play with the overlays in terms of which mapping system you want to use there? Do you want to have multiple overlays? Which are the different ways you can use to reduce the state on the overlay? So these are the questions that we have on the table right now that we will like to discuss and address in further iteration of the draft. So that's why we want to get some feedback from the working group on this. So that's all I have.
Two clarification. I mean, what do you mean by improved state reduction in overlay? This is,
so, for instance, think that you have multiple ways to register let me go one slide back. These guys here, the borders, they need to register the mappings from the local site overlays into the overlay. And you can take different approaches for that. So you can register the mappings as you get them from the local site, or you can try to aggregate as much as possible, but then the border needs to decide how to aggregate those. And then if there are gaps, you need to register the gaps and so on. So we need to discuss which is the best way to reduce the state that you need to register into the overlay.
Okay. So I'm thinking, because if we did a very good job and we have a massive scalable mapping system, you don't need this.
You're talking about the overlay.
Yeah.
No,
that you have a mapping system.
So that's fine. I mean, if we say, for instance, okay, the overlay is going to run.
I see the point. I see the point.
The point is, again, the administrative domains, right? Yeah. You may have a very scalable mapping system that does everything at the planetary scale, but there may be two organizations that don't want to use the same mapping system.
Or let me put it this way, right? So we can say, or the draft can say, if you don't want to aggregate anything and you're going to register the mappings as you get them, then you need a mapping system that is able to scale to a global scale. Mm-hmm. So that's the kind of considerations that we need to think of.
Then, can you clarify to me what is the difference between federated and what was your decentralized? What?
Do you want to comment before that, Dino, or shall I?
You have.
No, I was going to answer the previous question.
Okay.
I was going to give you an example on why it's better to have
state reduction.
Yeah.
Oh, okay, let's finish the state reduction in this case. Go ahead.
The analogy I was going to get is like if you have a single BGP process that's running with multiple VPNs, you can keep the VPNs separate, but they're shared by one process and one routing protocol. But if you ran two BGP routing processes that are completely separate and may have a different peering topology altogether, that would be the same as using Uberlays.
Okay. So yeah, the decentralized federated. So this is partially coming from the discussion that Victor and Fabio are having with the ICAO guys, right? So in the ICAO case, and this is not final yet, but the latest discussion is about how they can deploy each organization deploying its own site overlay, and then the overlay is federated. So no organization has control over the overlay, right? So it's not clear yet how that is going to end up looking like, but they were discussing, for instance, okay, each of us takes a map server in the overlay, and then we federate, so there is no single administrative domain for the overlay. So those are the kind of discussions that we would like to have in further iterations.
Okay, I see.
Yeah, so all these are open questions. That's why we put them in next steps. Mm-hmm.
So my personal feeling is that there is some work to do on this document. Mm-hmm. Still work to do on defining
it's an early document.
And what we need is more discussion on the mailing list if we want to go for the adoption part.
That's fine. That's fine.
I mean, if we discuss to solve all these not issues, we define what is, let's say, missing, then and we discuss this on the mailing list. then
Yeah, maybe let me
we
put it
will
this
reach
way.
the point where we will say it's ready to be adopted. I mean,
Agree.
if there is interest, etc.
Okay, yeah, that's fine. So that's why the first thing here is discussing on the mailing list. And I think that, what you are saying at the end is we need to agree on the scope of this draft, like what the draft is going to address, what the draft is going to cover, and then state clearly what the draft is not addressing or covering, right?
Mm-hmm.
Yeah. So that's perfectly fine.
Yeah,
okay.
exactly.
Good. Yeah, that's all good feedback.
Charter-wise, I don't think there is any specific issue should be covered by the charter that we have.
Agree. Okay.
So, yeah. Any other question? Okay. Thank you. Dino, you're gonna use your own.
Yeah, because I have a movie that.
Need to switch the HDMI cable. You show us a movie, The Avengers.
What's that?
It's a big joke. Let's go. Sorry.
Okay. Hi, my name is Dino, and I'm going to talk about this traceroute tool. This is just something I was working on to debug list networks a little bit better. It's pretty short. I'm just going to explain what we're trying to solve here. Let's see, which way should I look? So basically what I wanted to try to accomplish is trace the encapsulation path, the round trip path from an ITR to an ETR, or from an RTR to an ETR, or RTR to RTR, or depending on the number of things. So basically at a client that's running as an encapsulator, you would launch this list traceroute tool. And what it would show you is the underlying hops between the XTRs, because this is an encapsulation path, but there's a lot of network between there. So it would show you the underlay hops, and as well as the RTTs between the two list points. And it would work through NATs with RTRs in the path as well. And so it would work in this scenario here, where that if the ITR and ETR were other sides of the NAT, it would have to go through an RTR. So it would show the path from ITR to RTR to ETR, or through multiple RTRs. And of course, it works for an IPv4, IPv6 overlay when an IPv6 and IPv4 underlay is there as well. So the command line, it's a Python program. It's pretty simple. You can specify the LTR command with an optional source address. If you don't supply a source address, it picks a source EID from a configuration file that in the Lispers.net implementation. The destination could be an EID or a DNS name. The destination address can be an address or a DNS name of an EID or a non-EID. So from an ITR, if you wanted to Lisp trace route to www.cnn.com, you should be able to do that. This is what the output would look like. This is basically showing a path where the map caches are populated in all the Lisp routers. So it would show you example, and then I put the names out here. So it basically shows you the encapsulator, the decapsulator, the time it happened, and the name of the encapsulator. So the rest of the presentation just describes the fields. This is an example where there's a map cache miss. So let's say the ITR is wants to, we're basically Lisp trace routing EID 2.2.2.2, and the local ITR is EID 1.1.1. So his source RLOC with port number is there, and it goes to the RTR. The RTR decapsulates it, and then once the re-encapsulated, but it turns out it doesn't have 2.2.2 in its map cache, so it reports back to the source that there's a map cache miss. Go ahead, Albert.
Yes, this is Albert. I was wondering how this works. I guess that you infer that there is a map cache miss because you send a packet with a larger TTL and you don't see any next hop, or?
No, this has nothing to do with the original trace route, so it doesn't use TTL mechanisms at all.
Okay, then how does it work?
Yeah, I'll explain
Okay.
that was Luigi's question. He wanted to know how, not what. But and since it's not written up in a draft, there's source that you can look at. So But anyways, let me describe. So I guess I should have said at the beginning of the presentation, this is a presentation of the functionality of LTR, not how it does it, but I'd be willing to answer questions, of course. Okay, this is an example where you're tracing a non-EID. And so what happens is that the trace has to stop because there's no ETR. This is the last point along the way. So you're able to get to one point and the RTR said, this is a non-EID, so I was trace routing the Google DNS server. So just to show you some details is that the program is able to detect that it's behind a NAT. So what it does is it finds that since it's behind the NAT, it knows it has to encapsulate to an RTR. And so that's what it's doing at this point. The next line of output just says it's sending a round trip trace message from itself in instance ID 1539 to an EID that is registered in IID, instance ID 1539. Okay. And then a reply came back, which means the packet went to all these hops, went to the ETR, and the ETR turned the packet around, and that was done in 154 milliseconds. This was the path from the ITR's EID to the destination, and this is where it was turned around. So you see both the asymmetric path. Now this is pretty interesting because you can see if the encapsulation path takes the same or an asymmetric path. Remember, if you're returning the packet back to 1.1.1, it may not go through the same RTR because the paths are unidirectional. In this case, the encapsulation paths are symmetric. The underlying paths you never know, but you can find that out by looking at the RLOCs, okay? Now what's interesting about the ITR doing the encapsulation, it's saying that it's encapsulating with a source address of 10.240 from this port number. That's really interesting information because that's his local private address because the ITR is sitting behind a NAT. And what he's doing is encapsulating to a global address of the RTR. Now, when the RTR gets the packet, notice that the source address is not the 10 address, it's the 104 address because the NAT translated it. And notice that the packet was addressed to 10.240 because the RTR, which was in Google Cloud, was also behind a NAT. This is really important information when you're debugging. So now when the RTR wants to encapsulate going to the ETR, of course he's using his global address. And now he's using 35.202.144.92, which is the translated address of the ETR, and that's the translated port. And when the ETR gets it, he gets it on the address, or that's the address of the RTR, the source, and then that's his own address, which is also translated. So we're double natting like crazy through this path. But we need to find out what these paths are. What's also reported from the ITR's point of view is what his recent RTTs are. So the RTR is sending RLOC probes to all his RLOCs, and this here he's keeping the last 3 round trip times. So you can see that there was some variability here, 141 milliseconds, then 55 milliseconds, then 75 milliseconds. And in my implementation, I know the number of hops. So the number of forward hops from the ITR to the RTR is 5, and the number of reverse hops coming back would be 6. So that's useful to know what the diameter of your tunnel is. Okay, and then these are just Linux timestamps that are using UTC time, so they're synchronized because as long as they're configured correctly and there's some clock synchronization protocol running, you can actually look at one-way delay. So you can see that this packet went from 173.69.85 to 173.87. So you saw that it took 20 milliseconds for the packet to go in one direction. So you get one-way delay as well. Pretty useful. This is just saying we turn around the packets. And then that was the reverse path. That's pretty much it. So this is where the code is, so you can go look and see how it works. The way it works in a high level is it's part of the encapsulation path, and I implemented I added a new message called a trace message, and what it does is that when a trace message comes, it's actually processed, and you put JSON of information in here. And in this case right here, the JSON that's being put in this trace packet, these aren't data packets, these are control packets. The JSON for this entire round trip was about 800 bytes, which is kind of large, but that could be optimized as well. I did JSON because it was easier to debug reading it on a sniffer trace. So the idea is there's a trace that starts off, and the ITR, that basically the information it gets out of its map cache, it puts it in JSON and puts it in that packet, and then encapsulates that to the RTR. The RTR gets this packet, decapsulates it, sees it's a trace message, and takes the decapsulation information, puts it in the trace message, it appends it, and then now it's ready to encapsulate it. It puts the encapsulation information in that trace message, and then encapsulates it and sends it on. So that's basically how it works. It's exactly one message that's going out. That's one message that's being sent from here that goes to each of these hops and being returned. So it's really not a lot of overhead on the network. So I wanted to trade off the size of the packet with the number of packets being sent. So yes, if one packet gets lost, you'd have to type this in again. Or we could put command line parameters to put multiple probes if you wanted to. Questions?
Yeah, this is Albert. Do you have any plans to specify the protocol behavior that you need in order to implement that? Because I understand that this does not work with a standard Lisp ITR.
Yeah, right. It would not. It's absolutely true that the forwarding implementation has to change to understand the trace. And when I sent the slides to Luigi, I said, I obviously haven't written this down. I did the code first, but we can certainly write a draft if the working group's interested in it. So yes, I don't know. Do you think it's useful? Should we write a draft? Anybody want to help write a draft? That'll Hi, Prakash.
So you said in the original slide that underlay, it can also detect what are the underlay the tunnel is traveling through. Is it correct?
It knows the number of hops in the RTTs. I have another tool called Locator, LOC8TR, that actually will go to an ITR's map cache and actually go through the map cache, trace route to each of the RLOCs, and give you the actual physical hops. So that can be used in conjunction with this. The big question is should I use a detailed version and launch that tool for each one of these? So this arrow here has 5 hops. Do you want to show that information? That's something we could add.
So from the RTR2 message goes one for the tunnel endpoint and other for to detect the underlay?
No, it's a different program. It's a different tool altogether that just queries the map cache in the ITR. And for all the RLOCs that are in the map cache, then it trace routes each one. And it also pulls out this information from the map cache. So it's trying to marry the information that's in the map cache that RLOC probing is doing with the actual physical path using traceroute.
So 2 different tools.
Yeah. So merging it is, interesting, but this kind of gives you a rough idea what the underlay is doing, but really is showing you the encapsulation paths. I think as we go into the future, no one's going to care about the underlay because the overlay is where all the value is going to be. So long as these numbers don't change so much, right? If you see these things spike over time, then you have to find out, did I switch service provider and this another because of the path switch? The service provider is really slow. Maybe you tweak. I mean, there's things in Lisp proper we should do to say, this path is almost 3 times longer than this other path. Should we keep using the same RLOC? Should we switch over dynamically? It'd be nice if we could put work into that as well to show that, these paths, because now that you can do the switching and get better network performance on the overlay, because you have the RLOCs, you can switch back and forth, and you could do it as often as you want. You don't affect the underlay at all. So that would be interesting for somebody to look at, possibly.
Once you take the standard work for the graph work, you need to see how it will be different than the NVO3 path trees. Because they have their own message type and
right.
And they, I think, has some capability to do the underlay as well with the same message.
As an integrated mechanism. Okay. Yeah, that's a good suggestion. Yeah. I haven't looked at it, but it's a good idea. Thanks. Thank you.
There is a missing part, right? Because in order for this to work, you need support on all the RTRs, ITRs with your specific message.
Yeah.
So I need some code that is running on the RTRs. For example, the server part, listening to your specific message and
Yes.
getting the information. This is also on the GitHub repository.
Is it, what was the question?
Is it on the GitHub repository?
Yes. Mm-hmm.
Everything is
Yep.
okay. And
Yeah, every forwarding component, every ITR, if the system's running as an ITR only or an ETR only and an RTR that's doing DCAP and NCAP, all those entities have to change. And if they don't, I didn't try it, but if, say, this RTR didn't work, it turns out that this information would just not be part of the output. So you could skip over RTRs that didn't support it. But if the RTR doesn't support it, it's never going to turn the packet around. So it would just be a lost trace. So if the question is, can there be incremental deployability of this? Yes, but not useful. You really, so.
okay.
Thanks.
More questions? No? Switch to the next.
Okay. Okay, so this was really fun. We did a Lisp mobile node demo. The guys at UPC did a wonderful job of taking the OR code and actually make it run on iOS. And since I have an iPhone and I'm kind of on it 24/7, I was able to play a lot of Lisp stuff with it. So, a lot of credit goes to Albert Lopez, who was very fast in fixing bugs. And of course, Albert Cabellos, who was our oversight committee. He made sure we stayed in line, and he did all the stuff behind the scenes. I think he did, because everything ran so smoothly. So this is a demo of Lisp Mobile Node. And the draft has been around for quite a long time. I think 2009 timeframe or right after the working group, long time. And so it was an individual submission for a long time, but we made it a working group document. And I thought it was time to actually do some implementation so we could maybe move this draft along and see how good this idea is. What's really nice about Lisp Mobile Node is that a phone can be multi-homed and use any service provider anywhere. It does all the FMC equivalent stuff that 5G wants to do, and you don't have to talk to anybody in the middle of the network, because all the encapsulation and using the underlay can switch back and forth solely on the phone. So it's quite a powerful technology. So this is what we're demoing. We're gonna show Lisp Mobile Node on an iPhone, and I have some RTRs deployed in Google Compute Platform or Google Cloud and in AWS. And the Lisp Mobile Node is going to talk to, so CN in the mobility world, CN stands for correspondent node, which means it's a node on the internet that's not moving. So we're going to show that the Lisp Mobile Node is going to talk to another Lisp node that's on the internet, and we're going to show that a Lisp Mobile Node is going to talk to a non-Lisp mobile node. So that we're doing inner working as well to show that Lisp can talk to anybody. To make my iPhone useful and to keep Lisp running all day long, I want to use all my applications on it. So I want to be able to talk to non-Lisp sites. And we're using, so the inner working draft allows you to do route injection with a PITR or do something called LispNat. My implementation does LispNat. Go ahead, Albert.
Yeah, this is Alberto. Just a really quick clarification. So you are not showing it in the demo, but just because it's in the slide.
Yeah.
I mean, potentially we can have Lisp Mobile Node to Lisp Mobile Node as well. That's not an issue.
Absolutely.
Just to be clear on that.
Yeah, a great question. And there's one caveat that I'll talk about later about that, but I think you already know the answer to that. So some magic sauce. We're trying to do multiple efforts at one time. So the Lisp Mobile Node is not running a control plane. This is really important. It's not sending one Lisp control message. All it's doing is the data plane. And I'll explain what the motivation was there. Lisp Mobile Node basically is just configured with a 0/0, which means any IP packet that's sent is going to be sent to a list of Peter's proxy ETRs or RTRs, because in some cases they're re-encapsulating if it's going Lisp to to Lisp. The RTRs are configured to glean the XTR mappings. So as packets are coming in that are encapsulated by the phone, we look at the source port and source IP address, and we put that in the map cache so return packets can go there. So that means an iPhone could be behind a NAT and it just works. There's no NAT traversal logic that occurs. We have a NAT traversal spec that has a lot of control plane machinery, but we're not using that for this demo. Now, this is in an effort to implement a lighter weight XTR, make Lisp even simpler, less resource constraining, and one that possibly can run on dash cams, perhaps. And you're going to hear Sharon's presentation. So this was an effort to try to understand how lightweight we could put Lisp on small, memory challenged, or want to reduce the cost of it.
May I?
Yes,
May I?
go ahead.
Clarification. So it's been a long time, so I forgot the content of the document. So you have Lisp mobile node on your iPhone. So you don't live in Montreal.
I don't live in
Montreal.
Yeah, Montreal.
So now your iPhone is pointing to which Peter?
I'll show you all in the demo.
Okay.
Yeah. By the way, it did work when I was I'm sitting in Montreal. It worked on the cellular network too.
The point is, how do you change it? Because basically, otherwise you may have a long stretch in the past. It's always the same Peter. I mean, if it's your home, then your traffic is going back to California.
Yeah.
Even if you are connecting to something that is here.
Yes. Oh, I already experimented with it. It was very interesting. The RTTs doubled. Yes.
Yeah,
but it's a speed of light problem.
In some context. So the other point is,
you mean should the Peters be dynamically learned based on your physical location?
The fact that the Peters is fixed. Okay,
yes.
And you move around. This could be an issue in a certain way. So we have to think about this. I'm not asking for a solution right now. Mm-hmm. Okay. So the other thing is the RTRs are configured by gleaning, which
the RTRs are not configured by gleaning. The RTRs are configured.
Gleaning, XTR mapping.
The XTRs are gleaned.
So
on the RTRs, you turn on a command saying glean the information from the XTR.
But we have the document says not to do that.
The document says not to do that in public domains. Yes.
And this is clearly a public domain.
Yes, this is a demo.
Yeah.
This is not an RFC.
No. My point is that we have to keep this in mind, because if we want to move the document forward, I mean, we cannot have the basic specs that say you should not use this, and another document that say, oh, this technology is based on something you should not use. See the point? The gleaning.
No one's planning on writing a new document.
No. This document, the mobile node, if you base them.
The mobile node says nothing about gleaning. No. I mean, I understand your point, but we're not violating anything so far. Go ahead.
We'll check.
Go ahead, Fabio.
No, I think point taken, Luigi. I mean, there are two aspects that need to be considered. This is
I'm not criticizing the demo.
Understand. What are the
I know this stuff, so let's keep as a working.
What are the
keep it in mind, because.
So I don't want to discuss gleaning anymore in my life. But regarding the proxy TR, you are right. There is, but that's a message to the working group. There is no way to dynamically discover or change your proxy TR. And that's something that you realize when you start typing a code. That's true. That's something that maybe we can consider in the future.
Actually, it's not true. The list of Peters can be EIDs that are periodically looked up to find new locators. So we could put another level of indirection in the implementation to do that. It could work.
Yeah,
but
we have the right tools, because there is an LCAT. But I agree. And the second one, it's a more general comment, but we have been working in a Lisp mobile implementation for a long time, and we have had some deployments. I'm speaking from a university, so deployment for me is different than for other people, okay? So it's much smaller, but still we've got some experience. And 90% of the code of mobility is on NAT traversal. What I'm trying to say is that 90 or 95% of the complexity. The mobile node document is on the charter, as far as I remember, and I think that we should push it. But we should also consider that writing the code of a mobile node is writing the code of a node that is moving across NATs.
Yeah, that's a really good point because the Lisp mobile node document doesn't say anything about NATs. It just assumes we're in this pristine environment, which is not the capital I internet, where the RLOCs that the mobile node's registering are all in global space. So, I mean, a lot of these documents don't reflect reality, you know.
Excellent point.
Any other questions? Keep going. Keep going. So here's the topology. We have a phone, an iPhone that's connected to a cellular connection as well as Wi-Fi or multiple Wi-Fis. And I have also part of the demos, I have a Docker container that runs on my laptop. The mobile phone's EID is 13 and the container is 14. And what the plan is for 13 and 14 to talk to each other. And that should be able to work as the mobile phone switches from one connection to the other. But both of them should also be able to talk to these non-Lisp destinations, which is a DNS server at Google and my website, www.lispers.net, which is in wix.com. So it's just it's just a regular server host out there. These are the RTRs that are deployed one's deployed in Google Cloud and 3 are deployed in AWS. Okay, so the mobile node is running OOR, and the container and the RTRs are running my Lispers.net implementation. Okay, so this is the live demo. I decided to record it just because I didn't know what Canada was going to give me in terms of connectivity. So what I'm going to do is there's some audio. I think I can make it work by holding this here, but we'll see. Test. Let's try doing this. It's a mobile node demo. The first thing we're going to show is that the container at EID 14 is pinging the mobile phone at 13. It's happening right there. You see some pings going.
Can folks in the back hear?
You see that OR is enabled on the phone. And if we look at the settings, we'll see that it's EID 13. And when we look at a ping window, we'll see that it's on Wi-Fi. Yeah, I can cut. It's only 2 minutes, so I can restart it easily. Okay.
Turn off the audio and just
Yeah.
you speak to it.
Yeah.
Maybe sometime you post the video so you explain.
Okay, sounds good. Okay, so there's the topology. It's the same as the last slide.
Take the microphone.
Oh, let me, so I can stop when I need to. Okay.
You have the time. Let's do this.
Right.
So folks can actually hear it.
Okay, so so what we're going to show first is 14 pinging. I have to wait. So up there in that window right there, 14 is pinging 13. Okay, so that means the client ping on 14 is pinging the phone. The phone is configured with OR. There's the EID that's configured. And I bring up a ping program here. And what it's going to do is showing you that it's connected to Wi-Fi. See up there where my finger was. I actually could stop if I need to. Let's go back a little bit. Yeah, I can stop. Okay, so you see up there, it shows that it's connected on Wi-Fi at my house. And now I'm about to hit that ping right there. That's pinging www.lispers.net. Okay, and we're going to see the pings flowing from the phone to lispers.net, which is a non-Lisp site, from 13 to www.lispers.net. Okay, now I'm about to go back to the phone and switch it to LTE. And that's what I'm about to do now. I bring it down, I turn off Wi-Fi. And then if you look at the very top, let's see if we can catch the top. The pings are still running. We lost exactly one packet. Let me go up a little bit. There, stop. Up. Can you see it? Stop. See up here, it says LTE. So it's connected on LTE. The idea here is we're doing session survivability. The pings or a TCP connection would stay up as we're switching back and forth from Wi-Fi to LTE. This here is showing that packets are going from 13 to 14. Here's EID 13, here's EID 14. So the ping that the container was doing to the phone was happening at the same time. The dark green counters mean that the packets were encapsulated or forwarded within the last second, and the light green means they were encapsulated in the last minute. And the 185 is www.lispers.net. So you see 13 packets are going to 13 from 2 different places, and it's sending packets to 2 different places as well. So that's what that's showing there. And I don't know what I'm saying on the audio. Oh, I'm refreshing the screen now. So you should have seen the counters change there because I was refreshing the screen. Now what I'm showing is that 166 is the RLOC that AT&T on my cell phone's giving me. And now I'm switching back to Wi-Fi, and then I'm going to refresh the screen on the RTR to show that that address is changing. And you see it changed to 98. Not only did it change the RLOC, but it also changed the encapsulation port because it's going through 2 different NATs. If we go back and see the pings are still running there, and I think it's just stopping. This is the end of the demo, showing that the pings are running on the top window in the container, as well as the non-list stuff going from the iPhone. So there was basically, when this switch was happening on the local iPhone, iOS has gotten really good where it can still keep the old connection up while it's associating with the other connection. So really, in most cases, when I do 1 second pings, I lose 0 packets. When I do about 100 millisecond pings, I'm getting 2 or 3 packets that are being lost just for some switching that's going on. But basically what's happening is, as long as packets are coming from this guy who's switching, the RTR will then automatically latch to a new set of RLOCs. This was kind of the point that Albert was making on how this is super simple to not only implement, but easy to deploy. If we go back and we show what has to be done on the, let's see, if we just see what has to be, I wanted to show you the settings. Let's see if I can find, there's the settings. Stop. Sorry, it's a little blurry, but basically all that it has to be configured is the EID and the instance ID that it's in, and then there's a proxy ETR list where you configure the proxy ETRs, and then a DNS server. Notice that the map server and the map resolver aren't configured because this guy doesn't need to use the mapping system. The guys he may want to reach use the mapping system, but he doesn't because everything's learned through those RTRs. Okay, so what we try to do is, let's see if we could scale this out a little bit, and let's have the container sent to www.lispers.net, and let's have it be configured with 4 Peters or 4 RTRs, and let's load split the traffic there. And that's what we did. The traffic was load split. And I'm just going to show you with output that it actually works. I'm going to see if I can zoom in here. Is that coming through? Oh, wonderful. It's a little blurry, but let me see. Okay, so what, yeah, I know. Thank you, Joel. So what's going on here is the packets that are being sent to www.lispers.net, this is the iPhone, this is the containers map cache. And of course, he has a 0/0 through 4 locators, 1 in GCP and 3 in AWS. And you can see that it's load splitting packets across all of them. Now, what's interesting is this implementation is sending our load probes to the RTRs. So we actually know the performance of the RTRs. We can see that the RTR, it's 700 milliseconds to that one. I think that one was yeah, that's the Google one. And here are the ones in AWS, 227, 335, 218. So these RTT delays or these hairpinning of packets like Luigi's point brought up is something that's really important because obviously the path, if you turn OOR off, the path directly to www.lispers.net is on the shortest path on the internet, where now it has to go like this, right? So RTR deployment is something for further study as well. Okay, so we kept playing and let's said now it's time to do large packets. And so what I did for my iPhone was I decided to drive from my coffee shop to my house. And what I did was I wanted to listen to this new audio. So I was streaming the audio there. You can see it's going on. And then I liked it so much, I decided to start downloading some of the music. Well, I did that all over Lisp as well. So streaming audio and downloaded music while driving. And during that time when I was doing that, I switched between all these different connections. I was, Xfinity just has open Wi-Fi connections. So I was connected to that. And then I was switching back and forth while I was sitting at Pete's coffee shop, right? And everything was fine. And of course, I was switching from AT&T's LTE. I say 5G, laugh out loud, because the upper right-hand corner says 5GE, so it must be 5G. I didn't know I can get 5G without paying any more money. Well, not. So that wasn't the case. But I was able to be able to go to all three of these. As I was driving to my house, I have some weak loss or some dead ranges where my connection downgrades to 4G. So I saw it actually downgrade to 4G as well. I didn't check to see if the RLOC changed because I was driving and I couldn't look at the RTR, but I basically went back and forth to all these four things while this download was happening. And there was no audible packet loss that I was listening to. This thing ran for about 2 minutes, 1 minute or something like that. And so I was listening at it. So that was audio. Caveats. Lisp mobile node must send before it can receive, because its RLOCs are being discovered from data packets. If it never sends data packets, then there's no way the RTR can encapsulate packets back. So if you wanted to deploy a server application that was doing a socket listen and expect people to connect to it first, it wouldn't work. There's lots of ways around this by putting extra tools on the implementation to send packets or a background ping, but that's just a caveat. So two mobile nodes can talk to each other as long as they talk to another Lisp node or non-Lisp node first, and then they get up. That was your point, yeah. And of course, this was the Luigi point. Luigi's always one step ahead of me, right? Latency exists to learn Lisp mobile node when it is discovered, but less than doing a mapping system lookup. If we would have did a mapping system lookup or registered, it would have taken even longer. So, it's still not, is it good enough is the question. That's subjective. I don't know. And then we have this asymmetry problem where if Lisp Mobile Node 1 uses one RTR and Lisp Mobile 2 uses a different RTR, and they haven't they can't talk to each other, right? Because they don't have each other's RLOC. So Lisp Mobile Node would have to talk to the RTR that somebody else is using. So basically building a symmetric cluster of RTRs that you talk to all of them all the time makes you discoverable for other things that want to talk to you. What was nice is Albert Lopez just implemented priorities, and he does load splitting. So I was able to put all four of these just this morning. The code just came in this morning. So I was able to put all four of those RTRs in the OR implementation, all with priority 1. And since the iPhone was doing all kinds of stuff, just not my pings, I saw packets were being load split across all four RLOCs. So that was really nice. And you as a user don't have to care about this, but you as a technical user may want to set the priorities different. If you had 1 and 1 and 2 and 2, it would just load split across the 2. And eventually when we get RLOC probing working and you find out that the priority 1s have gone down, it just automatically switches to priority 2. So there's lots of robustness that the phone can do by itself to find better paths. It's really kind of nice. To-do list. We have RLOC probing works on OOR, but it's not interoperating with Lispers.net, so we have to figure out how to get that to work. But if we do RLOC probe, we could do the sort of things I just mentioned. And then the question is do we need crypto? If we can do Lisp crypto on the phone, everything that leaves the phone, regardless of what service provider you run over, will be encrypted. And it will be encrypted all the way to the RTR and can be encrypted from an RTR to another Lisp node. If it goes to a non-Lisp node, it obviously has to be unencrypted and then sent as it is in the thing. So there could be some security that's added, so we can maybe do some experiments with that in the future. And do we need multiple EID support and instance ID support? Should the phone be part of 2 different instance IDs? One, maybe a work instance, a work VPN, or a private VPN. That might be interesting to use. And do they use different addresses? Are the EIDs addressed from a global registry versus an enterprise IT department or something like that? And of course, no job is finished until you do multicast. And I have been able to do multicast from the phone. So if I ping 224.111 from the phone, the packets go to the RTRs. That's wonderful. So the single 0/0 map cache entry even handles multicast. So I think it's going to be easier to do a phone OOR being a multicast source versus a receiver. A receiver, we would have to make sure that the app supported IGMP and that the IGMP stuff uses the signal-free stuff. So we have to figure out if there's a simpler way or we use the existing mechanisms. What's the cost of the implementation? Do we have to get Apple or the OS vendors involved? All that kind of stuff. But anyways, that's it. Questions?
To the mic, please.
Mike, could you go to the mic, please?
Yes, Prakash. This RLOC probing won't cause any scalability issues in the network? What is the
Well, certainly less is better. So not doing it is better than doing it, right? The question is so Apple does a good job of testing the Wi-Fi signal. And if it's not good, it automatically switches to LTE to give you some better performance. Should we be smart enough to know that the Peters aren't doing well without RLOC probing, which may be your point, and maybe turn it off and then try to go native, and then you lose the session survivability multi-homing because the network connectivity isn't good. I found that here a little bit too by roaming around was stuff wasn't working. I'm going, what's going on? And it's the IETF hotel Wi-Fi network that's kind of bad. So this is a great environment. I'm going to be doing testing. In fact, I'm going to be testing all this week. If anybody sees me walking around and they want a quick demo right there, I just have to pull out my wallet and boom, or pull out my phone and I could show you. So there's a lot of different access points that have these bad characteristics. But your point is taken. Should you just RLOC probe a few of them versus all of them, because there's all those phones are going to be RLOC probing the same ones. But I have a feeling we're going to have location-aware RTR deployment to solve the Luigi problem. So maybe not all the phones in the world are going to probe the same 4 RTRs or the same 100 RTRs. They're going to be locale-based. But it would be nice to look at how to deploy something like this on a large scale. Yeah, absolutely. Oh, I don't know how we're going to exchange Lisp crypto keys dynamically without RLOC probing, but unless they're PSK static or something like that.
How you protect the exchange with the RLOC probing? I mean, you are exchanging keys, right?
They're public keys. It's a Diffie-Hellman exchange, just like TLS does, so it's no different than that. The secret keys are built independently. Yeah. Okay, sounds good.
The Lisp crypto is something nice to see on the mobile node.
You think that would be a compelling thing?
I think so.
Yeah.
Just about my opinion. I had a second question. If you say multiple EIIDs and multi-IID, so when I install a new application, how to figure out which EID to use, which IID to put in? I mean, OR would have 0/0, everything goes through. Now, if you have multiple, then you need to choose which one is your source ID.
Right. OR right now defaults to adding that, but it could add any type of routes. It'd have to be destination based. You would have to say anything that goes to, if I'm a Cisco employee, anything that goes to Cisco use my VPN and therefore uses that EID versus something else.
I see.
Okay. Now, how is that done seamlessly for the user? That's deployment code that has to be written. Yeah.
So I think that this is Albert. I think that Albert and I still have the same thought here. So if you want to have multiple EIDs on the same phone, you may need to work with the OS vendors, because as far as I know, neither Android or iOS allow you to have multiple VPN interfaces.
Yeah.
So you can enable
solve it that way, you're saying.
I mean, as of today, we need to check, but as of today, you enable a VPN either on Android or iOS, and then you associate applications, route, as you were saying, to that VPN interface, but that's a single EID.
But you can create multiple VPNs.
That's what I'm not sure about.
Well, there's multiple VPNs on my phone right now from different versions running, but they're not all used at the same time. Can they be used at the same time is another question.
Okay. So your point is, I'm going to turn down this IP VPN and start a new one with a different EID.
Yeah.
That can be done.
But that would be an OR implementation choice if it wanted to solve it that way. But, yeah.
OS might not allow it because you are becoming a gateway between domains.
Well, it may only allow you to have one socket down because of the permission stuff. So yes, you're right. I agree.
Okay.
Yeah.
Right.
I have a small question. Do you need to jailbreak your iPhone to install this stuff? Good.
And you can download the latest version at the App Store. So if anybody wants to try it, go ahead and I'll give you the addresses of the RTR. Actually, you already know them. So I'm expecting a DOS attack after this, right?
Thank you.
So the last presentation is Sharon.
Go ahead.
Okay, hi, I'm Sharon. Present the mobility network based on Lisp. It's a specialized network. But actually, for me, in the last more than 10 years, specialized network is where Lisp really shines really nicely, more than just generic networks. This is one of them. It combines Lisp with a grid of the Earth called H3, which divides the Earth into hexagons. And we are using Lisp for mobile nodes and for addressable geographical locations, so I can talk to geostates. There's actually an additional standard which is combined in here. It's called BDD. It's a consortium. The Berkeley Deep Drive, which is stating what is worth noting about the road, about the geostates, which is worth communicating. So mobility networks communicate information about the road. So I'll repeat some of the motivation quickly. I did it yesterday in the hot RFC, if somebody heard. And then we're quickly going to dive into the draft itself. There's been a lot of work done in the last 3 months. So as you're all aware, there's a lot of cameras in the streets, in the roads. Specifically, my company deals with dash cams. We distribute a lot of them. There's hundreds of thousands, tens of thousands active in each city. But there's others that we've been working with. There's cameras on junctions, part of the infrastructure, roadside. There's other sensors, and they're seeing the world. So the drop of prices of cameras is not only price reduction, but also being able to understand what the camera sees. It's now very feasible to have AI that understands already at the customer edge what is being seen at the junction or at the car. We pair dash cams with iPhones, and that means I have smart eyes crawling the streets, just like Google crawls the web, but for the physical world artifacts. Okay, so we understand what we see. The question is, how do we communicate? And yesterday I explained that there are two networks that were available to do that. One is an offline network, which is kind of like builds a map, which can tell you the state of a traffic sign, but not the traffic light timing, or if the traffic light is out. There's always a delay, a gap of at least 15 minutes, if not more. There's also a real-time network, which today is by a standard called DSRC. It's a layer 1 through 7 peer-to-peer network for cars to tell each other what the conditions, share information about the road. So when I mean share is I'm not sharing with you that you're going to hit me in half a second. That's something for the sensor to pick up. But for example, if I'm going to turn a junction into a problem and be stressed out in negotiating my way out, let's say a double parking, and many cars see the problem, they can communicate it to me beforehand in real time. And that's where peer-to-peer falls short, and Lisp Layer 3 can really help us. Why? Because I may have timing issues when who saw the problem. Maybe somebody saw the problem I'm turning into but drove away. Maybe I'm rushing into a highway slowdown, but there's nobody to tell me that I'm rushing to a highway slowdown. So the information is up in the air. And we've seen a lot of pileups, and I have a lot of footage of pileups from Nexar cameras from the last winter. And so the idea instead is to wrap up all these annotations and put them in tiles, which represents the physical world. We tiled all the roads based on hundreds of millions of miles and based on maps. And now when I see something, I'm going to report to the tile. I'm going to talk to the tile. No car will talk to any other car. There's no privacy problem. There's no timing problem because the tile is always there. And I'm going to use Lisp EIDs both for the publisher and the tiles and to subscribe to the information about the roads. So all this is going to be combined use of Lisp based on H3 IDs. So we did a lot of work. I mean, this group here, especially Dino was the whip, to get some detail into the draft. And I want to go over some of the progress made. With your permission. Okay. All right. So what we have is a partition of the timing of the roads using H3R15. These are 1 square meter hexagon tiles. I think we talked about before why hexagons. It's almost a circle, but it tiles really elegantly. You can propagate neighbors if there is a stop vehicle and who is impacted. And it is very elegantly hierarchical. There's a very nice structure. Every 7 hexagons sort of make up a bigger hexagon, So these cars, as you can see, not only they see stuff, but there's a technology to localize it, which is where is it? How far is it from me, from the camera? And what is it exactly? So all that translates into ID, which tile, and an enum, which is what do I see? Okay, I see something in this tile, but I also see something in this tile. I have the technology to do that. So there's 64-bit to tell me what is it that I see, and 64-bit to tell me which tile of the Earth, specifically accurately describing where exactly on the Earth is that annotation. So that is communicated through the Lisp routing mechanism, and routing here is critical because if we are going to simplify safety and networking from DSRC layer 1 through 7 to layer 3, we absolutely have to control the latency because no matter how many advantages we're going to have using a pure layer 3 IETF standard, if we're going to miss use cases because of latency, then we will not be able to push that use through. It's always going to be impaired by this bar. And I'm going to describe what we did using controlling latency, what kind of timing we were able to get to with some AT&T test beds. All right, so how does it work? Just like in Lisp mobile node, the mobility clients, okay, they have a Lisp endpoint, which is non-control plane. When you start a ride, you get an EID through the generic network. You AAA, you authenticate, blah, blah, blah. You start a ride. You get an EID for yourself and an RLOC for your edge RTR, okay? And then you begin to ride. We load balance the RTRs in the city so that all the cars will be able to engage the RTRs in a given metro area. The latency here is fixed. It's the RF plus the metro area network. Okay, so now we want to exchange information. Why? Because this car sees this car's future and vice versa. So we want to share the information about the road, the state of the road, using the Lisp network. The client, once he identifies something exactly where it is and what it is the enum, he sends that information to the tile. What does that mean? The R15, 1 square meter, is algorithmically translated to the R9, which is 100,000 of those, okay? And that's another HID, algorithmically by bit operation. And the R9, okay, is translated algorithmically to a Lisp EID, okay? So now I'm sending a packet from an ephemeral car EID to a state EID, the R9. I'm telling you, here's something I saw here. Okay, you may not believe me, you may require a few of these, but I can talk to the tile instead of talking to other cars. That packet reaches the edge RTR, which then looks up where is that R9. So we're going to deploy in carrier conditions, and by placing the R9s in locations, R-locks, which guarantee latency, as an example, we were able to do the following. A car was rushing through a junction, about to breach a red light, 100 kilometers an hour. Before it breaches the red light, the camera understood it's going to breach a red light, the junction camera. It propagated information to the tile, from there to the cars which are involved in that junction. All of that in the time it took that car to drive another 20 centimeters. So everybody knew about a red light breach before the red light breach. And this is only possible if you control the routing. So the edge RTR is going to look up where did I put that state? Where is the R-lock of that state? Or which other edge RTR it's connected to. And then it's going to route the traffic just like normal list to the edge RTR, and from there to the control plane less encapsulator in the R9 state container. Okay, is that clear? Okay, I'm seeing something, it's in this bigger area, okay, and I'm telling that area, that's what I saw, okay? So the goal here is to have efficiency, meaning as bigger aggregation as possible for efficiency, so I don't have too many addresses. So R9s in a metro area, there's about 20,000, okay? But not too big, such that when I'm going to update other cars about what's going on, I won't have too much information to tell them, which is not relevant to them, okay? So an R9 is big, is 100,000 R15, but only 1,000 of those are road. So 1,000 fields of that is going to be updating the interested cars, okay? How does that work? Okay, if publish is unicast, is clear. Updates are Lisp multicast. What multicast? If you're familiar with 83.7? 78. Signal free, okay? It's a multicast which does not propagate in an unknown way across the network, just like in traditional IGMP, but it's based also on the mapping system, meaning that R9 address is now a public safety channel, okay? So I know it is registered here as the public safety channel, but also whoever drives into that R9 knows from his GPS that he needs to tune in to this public safety channel, okay? So he sends an MLD to his edge RTR from his data plane XTR to the edge RTR that I am tuning into this public safety channel. I mean, if somebody is breaching a red light, I want to know. So that edge RTR then registers in the mapping system to that he has a customer for that public safety channel, which is this block or the other block, okay? And from now on, I will know if there's an emergency vehicle, if there's an accident, if there's a stalled vehicle, if there's a tree branch, if there's a deer, if there's flooding. I will know because somebody will update the R9, and the R9 will propagate using signal-free multicast. So signal-free multicast, I'm not sure it's good for everything, but for this special network, it's very, very good because there's many channels with not so many subscribers to them. Okay? So basically, this is how it works. The integration is going on with multiple companies. We think this stack for mobility, which adds to the generic stack, can help multiple companies engage in using Lisp as a mobility network, specifically Intel, Toyota, and specific carriers like Verizon, AT&T, and LGU. We are also integrating tuning into the public safety channels with navigation apps that are now going to see as an overlay, as a graphical overlay, the condition ahead, heads up for distressed driving and not to get into hard to negotiate road situations. Overlay right there on your navigation app as a kind of a strip. So by factoring out state and making it addressable, we opened up the system. We are making interoperability easier. There is interest to host these states, to interact with these states, and I think we brought it to a maturity level which is pretty reasonable and hopefully become part of the work group items going forward, because mobility is quite important these days. But we kept the draft such that it does not change the Lisp protocol. So changing from HIDs to EIDs is algorithmic. There's no need for special consideration. We use RFC 6830 and signal free in a very specific way, which we have documented. We added enums of the BDD in order to do that, and we are able to sort of give development kit or just make people use Lisp mob stacks so they can integrate mobility clients, first responder applications, command and control by highway patrols, and other such applications in the entertainment center, in cars. So the potential for interoperability here is really cool. That's about it.
I think you've covered the material on the next couple of slides already.
Yeah, this is about it. If there's any questions, consideration, I know it looks like a kind of specific application, but it's really about open, interoperable, absolutely controlled routing, where is the state, and how it's being talked to.
Yeah, I want to make this is Fabio. I want to make a comment on why I think this use case is very interesting for Lisp. And if you can leave this slide, I think it helps a lot. So we are seeing a use case where that brings together the use of mobility with an overlay, the use of the mapping system to map something not as traditional as EID to RLOC mapping, as we have done so far. And also that try to take advantage of the locality of the service offered by the mapping servers that are storing the mapping itself. And then on top of that, using signal-free multicast to basically reach efficiently all the devices that are subscribed to a certain information. So it's a combination of use cases that are basically bringing together things that in the last few years we thought were possible with Lisp, but what I think is very helpful of this use case here is bringing all together in one use case with a very clean practical application. Also, I agree with Sharon that this is specific to this particular use case, but I think it's not very hard to think of other use cases that are not related to vehicle mobility and traffic road conditions that may have similar attributes, right? You want to have basically a mapping service that is highly distributed, available at the edge of the network, that offers you quasi-real-time information. So I think this is very general in many applications that we see coming up. So that's why I think there is a lot of value in working on this use case and basically trying to see how all the things that we have done in the LISP working group fit together. And it would be interesting to see if, there are new things that are needed. It's very nice that so far, most of the requirements that Sharon articulated seems to be addressed by what we have in the overall LISP architecture. So this is a very useful, I think, activity for this working group.
Yeah, thank you for that, Fabio. I'd like to add that there's in this with many things, we selected what is very tuned to this use case, and we use it in a very specific way. But it's also important for us to stay in contact with LISP evolution. For example, if I have a deployment in Verizon and in AT&T, I would need an overlay. So it's important to stay with the evolution of LISP, even though there is a twist here, which is we're talking to tiles, and that's the twist here, the brokering.
Okay.
Any more comments or questions?
I just have a question.
Name for the minute
This is
taker?
Dino. If we just wanted to publish this as a use case and made it informational RFC, what are the steps we have to go through? Does it require the working group? Does it not? Do you have any preferences?
Okay, the question of how to advance the document turns on a different point than the IETF procedures. In terms of our charter, it's okay. We could publish an informational document. Because this deals with geolocation topics, I'm trying to find out from the geolocation experts here at the IETF how they want to make sure that appropriate review from the teams who have dealt with these problems before, because this is not a new topic to the IETF. The usage is new, but the general topic of communicating information about geolocations and such like is one that they've worked on a lot. So I'm going this week to talk to some of the people who've been involved with that historically and figure out a good path. Because, speaking personally, not as chair, I like the work. As chair, I need to figure out what the best way is to get the appropriate review and appropriate progression.
So Joel, just one comment on this. It's true, it's geostate, but the thing here is that it's a brokered network using shared state.
There's no
happens
question.
to be geostate, but the shared state is the principle.
But historically, there's been sensitivity when we deal with geographic information. So I want to make sure I want to make sure we get the review and involvement from the people who've been in that space. And I don't care which working group ends up owning the problem. It may be that what we'll do is ask you to present this material at the apps area group next time or something. I've got to talk to folks. I've talked to one of the apps ADs. I've talked to some of the others. I've talked to some of the geolocation people who've been involved. Turns out Richard Barnes, whom I'm on another committee with, was very active in that. We'll close the loop and find out the best way to move it forward.
So on a personal note, I appreciate this peer review to keep grilling this thing.
We're not going to throw you out of LISP. Don't worry.
Was that a response to making it informational or just any type of working?
Just whatever type. It looks to me like it's mostly informational. It needs just to define a new LCAF, but that's all. And the LCAF registration procedures would allow that. But that's a nit in the picture as far as I'm concerned.
All right, thank you.
Thanks.
We're done?
Okay, we are done with the presentations. We have a few minutes left if anybody wants to make a question or discuss something working group related, obviously. Nope. So we will meet each other again in Singapore in 3 months or so.
And see you on the list.
If you didn't do it, please sign the blue sheets. There. I will bring it to the...
people can stay on schedule. It was good.
Yeah.
Thank you for that.
Just let me check this again. I don't want to leave something open. Yeah, works. Excellent. Thank you.
I managed to find Alexa, and he said, "Can you talk to the others, but you probably need to talk to Richard." Turns out Richard and Alyssa were the two people who were really key in that. Alyssa, of course, is too busy to even think about it. So I will see Richard tomorrow morning, so I'll be able to talk to him. Thank you.
Thank you very much.